Hello and welcome. In 2A, we will be talking about units and unit conversions. So to begin, let's quickly review what a unit is. If I just throw out a number, say 20, it's a little bit difficult to know how much 20 is. Is it $20 Canadian? Is it $20 US? Because that would have different values. We could have $20.20. We can have $20, $20,000. So what we have to do is to include the unit, the word at the end, that help us describe what the number is. So let's look at the example over here. We want to find out the price for each pound. Whenever you see the word for each pound, for each, that means that we have to divide. That means we have to divide. We have to divide the price by the pound. So we take $8 and we divide it by 10 pounds, and this will look like this. We put it into our calculator and get 0.8. And what this means is that we have $0.8 per pound. And we usually use the word per pound to describe that, to describe this unit, dollars per pound. And that tells us that in one pound, we have 0.8. It costs us $0.8. Now we'll talk about what per and off is later. We'll use them later on. But what I want to show you right now is a couple of other things. Sometimes when we are multiplying numbers of the same units together, so for example, if I'm measuring a box that is 6 inch by 4 inch by 10 inch. What you'll notice is that besides multiplying 6 by 4 by 10 and getting 240, we also have to multiply the units together. Inches times inches times inches 3 times means that we have inches to the power of 3. To the power of 3, we usually read it as cubic. Okay, so cubic inches. So if you see us write cubic inches as the unit, that means it's inches times inches times inches, inches cubed. That's what it means. So some of the units that you will see that's written down, we might not always give it, we might not always write it in the abbreviated form. We might write it in words, in complete sentences. And whenever we have kilometer per hours, that means we are taking kilometer divided by hour. And what the unit tells us is that 1 hour we travel 50 kilometers. You might see the units with a hyphen in the middle. The hyphen tells us that we have two things multiplying each other. So for example, the batteries in your cell phone will have a unit like this, 36,000 milliamps hour. We would just call this milliamp hour. And what it is that we're taking the milliamp and we're multiplying it by hours. So for example, when we're charging our phone, if I can charge my phone at a current of 18,000, if I can add 18,000 into our battery, and I charge it for 2 hours to charge it up to the maximum, that means that my battery fits 36,000 milliamp hour inside. And as you use your phone, you slowly use these up. When we calculate the area, for example, we will multiply two numbers together. And if I multiply meters with meters, I will get meter square or square meter. Both ways are acceptable version of how we say the unit. When I have three of the same units multiplying together, I would call this cubic feet or feet cube. So whenever you read the units that you are required to find, this tells us how we should go about finding that unit. If we have something that's in kilometer per hour, that means we have to take kilometer and we have to divide it by hours. Now, a couple of other important pieces of information to tell you. I cannot add or subtract number with different units. Let's say I have $10 Canadian and $10 euro. That doesn't mean that I have $20 Canadian because the two are different units. I can't just add them up and say $20, $20 Canadian, $20 euro, right? That doesn't make sense. And oftentimes, if we're dividing like this example over here, it might be more helpful to write it as the reciprocal, to write 1 over 2 hours and multiply that. We'll show you how we use these later on. But first, let's do some examples of identifying the units that we are trying to be looking at. So in the first example, we want to take the price, take the cost, and we want to divide it by the number of liters that we're drinking. So the unit would be dollars per liter because we are dividing. For the second example, if I'm looking for the area of a circle, we're going to take the radius and multiply it by each other. Pi doesn't have units, so we don't have to worry about it. If I take the radius multiplied by the radius, I will have centimeters times centimeters or square centimeters. Here we're trying to find the volume. If I'm taking acres and I'm trying to multiply by feet, then I will just have acre feet because I'm multiplying. Now, so far, we've just given you sort of helpful hints to help you solve the question. All the questions that we'll give you, on this section, whether it's on the assignment or on the exams, will be unit conversion questions that will look like this. We'll ask you to change a unit, say 140 pounds. Let's say someone weighs 140 pounds. And we want to change that into kilograms. Now, don't worry if you don't remember how to change from pound to kilogram. We will always give you the conversion factor on the side. So we'll always tell you 1 kilogram is equal to 2.2 pounds, or 1 pound is equal to however many kilograms. We'll give you one of those things. The most important thing to do when we're converting units is to understand that we can write the conversion factor, write this equation, and we can write it as a fraction. And this fraction is equal to 1 because 1 kilogram is the same as 2.2 count. Then what we will do is we'll take the number that we start with, 140 pounds, and we'll try to convert that into kilograms. What you'll have to do, what you'll have to remember is this. If I start with pound at the beginning, I want to write my conversion factor with pounds in the denominator at the bottom. We don't want to use the other one over here. The reason is because I can then remove the common factors. So pound is now gone. We change pound into kilograms. On your calculator, because the 2.2 is in the denominator, we will take 140, we'll divide it by 2.2. We will take 140 and we'll divide it by 2.2 because the 2.2 is in the denominator. Now I don't have to multiply by 1 because if I multiply or divide it by 1, that doesn't really change anything. So I don't have to worry about that. And then I press the equal sign, and that gives us the answer. The answer is roughly 64. The answer is roughly 64. Oops. So all the other examples I will be showing you today, you should pause and see if you can try it yourself. Now, in this particular one, we haven't given you the conversion factors, but it should be easy enough that you know that in 1 hour, there are 60 minutes and there are 60 seconds in a minute. As I put them together, what I'll do is I'll change the hour into minutes. Because I start with hour, remember, we want to put the hour in the denominator at the bottom of the fraction. So put 1 hour in the bottom and then put 60 minutes on top. Now we'll do the same thing to change from minutes to seconds. Now you can do this in 2 steps, or you can do this in 1 step like I did. Now, what I want to show you is this. When I change from hour to minutes, now you'll notice we have the minutes on top, right? You'll notice we have the minutes on top. So we want to, for the second conversion factor, we want to put minutes at the bottom, 1 minute at the bottom in the denominator, and then the 60 seconds will go in the numerator like that. By doing so, we can remove the minutes. And now when I multiply everything together, I'll call up my calculator. And what we'll have to do is we will take 1 hour, and notice how the 60 is in the numerator at the top of the fraction. So I multiply by 60. I don't have to worry about the 1, that doesn't change anything. And then we'll multiply by 60 again. And that gives us 3,600. The reason why we use conversion factor like this is, remember, the conversion factor, 60 minutes divided by 1 hour, that's equal to 1. So if I multiply by 1 all the way through, that doesn't change the size of my 1 hour. All we're doing is then just changing the unit. To look at the power, when we have something that's, when we have units that's in power, it's a little bit tricky. There are 2 ways to look at this. So let's look at the first way. If I know 1 yard is 3 feet, how do I change square yards to square feet? Now we can look at the yards and we can say that, oh, this is just yards times yards, right? That's how I get the square. And since 1 yard is 3 feet, I can just replace the 1 yard with 3 feet. So then I would have 3 feet times 3 feet. That's 9 square feet. So that's method number 1, to find that 1 square yard is 9 square feet. There is a second way. The second way is to look at 1 yard equal to 3 feet and realize that in order to get to square yard and square feet, I have to square both sides. On the left, I just have 1 square yard. But on the right, I have to square the 3. Right? So the 3 becomes 9. 3 squared is 9. 3 times 3 is 9. And you can see that that's what happens in our when we consider the diagram, right? 1 yard is 3 feet. 1 yard is the same as 3 feet. And then on the other side, 1 yard is the same as 3 feet. And then when I multiply them together, I get 9. Here we'll have 2 more examples. You'll notice that we'll always give you the conversion factor, so you don't have to worry about it. So in this question, we have 120 square feet. How many square yards is that? You notice the conversion factor doesn't have square feet inside. So we have to do an extra step to find out what the conversion factor is for square yard and square feet. So the first step would be to do that, to do what we just did on the last page. Once we know that, we can then take 120 and notice how we have square feet as the unit, right? So I want to put this 9 square feet in the denominator like that. Remember, always put the same unit in the denominator so we can remove it. 120 divided by 9, that gives us 13. So 13.3 square yards. The other unit that's left. For the next example, we want to change from cubic meter to cubic centimeters. So we have to take our conversion factor and find that that's what we get. How do I do that? Remember, there are 2 ways. And I think the easiest way is to look at my conversion factor and notice that I need a cubic. So what I'll do is I'll take one side, right? And then I'll cube it up to the power 3. And then I'll do the same thing on the other side. And then I will cube this to the power 3. So on the right, I get 1. And on the left, if you do 0.01 times 0.01 times 0.01, you'll notice that that will be, and if you put it into your calculator, that will be 0.000001. And when we put them in to our equation, we start with 0.3 cubic meters. And because I have cubic meters, I want to put the cubic meter part in the denominator and leave the 1 centimeters cube on top. We will always have to look to see which part goes in the denominator and which part goes in the numerator. Then you will put into your calculator 0.3 divided by 0.000001, and you should be able to get to 300,000 as our answer. You'll notice when we have the centimeters that we just used or kilometer, these numbers are really nice rounding number, nice round number in the power in powers of 10. And this is called the metric system. And in the metric system, for example, the word kilo means 1,000. So kilometer is 1,000 meters. 1 kilogram is 1,000 grams. Same thing with the other units. Milli means 0.001. So 1 millimeter is 0.001 meters. 1 milligram is 0.001 grams. And we don't really have to memorize the units over here, because on the test, on the exams or the assignments, we will write down the conversion factor for you. But I just want you to know that these units, right, you don't have to remember them separately. Like we don't have to remember a kilogram, like when we use them in everyday life. Kilogram and kilometer, they're not really completely separated, right? They both have the word kilo in there, and it should help us and say that, oh yeah, that means 1,000. Sometimes we'll have a question like this where we have to convert the unit conversion 2 times. Here we want to convert from 1 centimeters into nanometers. So this one is centimeters over here. And I'll tell you on the assignments and exams that this is equivalent to 0.01. When I write my equation, I start with 1 centimeter. And remember to put the centimeter in the bottom in our unit conversion factor. The 0.01 meters will then go in the numerator on the top. Now this will allow us to remove and cancel out the centimeter. So we're left with meters over here. Then what we'll have to do is we will put the meter in the bottom. So we'll have the 0.0000001 meters in the denominator. Because we have meters on top, we need another one on the denominator to be able to remove the meter. 1 nanometer will then go on the top. In my calculator, oops. Oh. So using my calculator, I will start with 1, and we will multiply by the 0.01 because it's in the numerator. It's on the top. So times 0.01. But this number is in the denominator at the bottom, so we will press divide. So we'll divide it by 0.000000001. Okay. And we get to 10 million. So our answer is 10 million nanometers. One final thing, when you go to the currency shop to exchange money, usually you'll see 2 different numbers. You'll usually see 2 different numbers. And what the 2 different number means is that it usually means that that's the value that the store will buy the currency at, and what the store will sell the currency at. And it's different because as they buy and sell, they will buy at a lower price. The store will buy at a lower price and sell it back to other people at a higher price. And that's how the store makes money. So if I want to figure out that I have $200 Canadian, how many Korean wons can I get? What you'll do is that you will pick one of these numbers and do our conversion with. If you're not sure which one to use, it's whichever one that gives you the lower number, right? Because the company wants to make money, so they will always give you the lower amount. So in this particular case, because we are trying to get Korean wons, Korean dollars, then we need the store to sell us the Korean dollars. So it will be the 0.001234. And when we do our calculation, because I start with $200, I want to put the 0.001234 in the denominator like that. And that will give us 162,075. Now, if you do the same calculation with the other value, with the other conversion value, what you'll notice is that when you do the calculation, the number will be bigger. The number will be bigger. And of course, the store is not going to give you more money because the store is going to try to make money off you. So the actual number that you'll get is always the smaller.